Look at this silhouette. It glides down the road almost silently. No vibration, no exhaust, just a clean, swift outline reflected in the rain-soaked asphalt. This is a new electric sedan from a Chinese manufacturer. Many experts call its design the most harmonious in the modern Chinese automotive industry. But this is not about the brand of the car, nor the manufacturer. It is about the driving force, and it is something far more astonishing than a simple electric motor. We are looking at a technology whose key element is abundantly dissolved in the ocean and found in every kitchen. This is not the energy of the future, this is the energy of the present, and it costs less than in the past. Here at the Living Planet, we are exploring how a technology hailed as the breakthrough of 2026 could change not only our electricity bills, but our entire relationship with the word scarcity. For decades, the world was hooked on expensive metals. To understand the difference, sodium carbonate, the raw material for these batteries, costs between $100 and $500 per ton. Per ton! Meanwhile, lithium carbonate over the same period soared to $83,000. Do you feel the scale? Engineering circles say that extracting sodium is about 20 times cheaper than the lithium race. Today, in the spring of 2026, the cost of a sodium-ion cell ranges from $55 to $70 per kilowatt-hour. That's from MIT Technology Review and CATL suppliers. Analysts from China and Hina Battery are confidently looking at the calendar. Next year, in 2027, price parity with cheap lithium iron phosphate batteries will be reached. And then, pure economics kick in. Scaling up production, according to calculations, will drop the bar below $44. And then pure economics kick in. Scaling up production, according to calculations, will drop the bar below $44. We often ask ourselves, where is the boundary between good enough technology and the endless pursuit of maximum efficiency? If a battery is 30% cheaper to run, maybe we don't always need the most powerful battery on Earth. Just 3 years ago, sodium batteries were mere laboratory curiosities. Today, it is the dawn of the gigafactory era. CATL has already put its Naxtra cells on the assembly line for mass-market passenger cars. That very elegant is living proof. In Hubei province, China launched a 200-megawatt hybrid storage station. Elon Musk once called the gigafactory a machine that builds machines. Now, China is building factories that print energy from salt. Yes, this technology has objective physical limits. An energy density of 150 watt-hours per kilogram does not yet allow for flying airplanes or driving 1,000 kilometers without stopping. This is a niche for cities, delivery, and power grids. But progress does not stand still. Scientists from the Chinese Academy of Sciences and Hina Battery have created a prototype with a density of 211 watt-hours per kilogram. And a lifespan of 20,000 charge-discharge cycles from BYD means that such a battery can outlive the body of a car or work for decades at a substation. The question arises, can a technology designed to balance power lines become an unexpected and very quiet competitor to lithium on the streets of our cities? In a life cycle assessment, the picture is more complex than a simple green label. The obvious plus, we are moving away from cobalt mines and dried-up lithium lakes. We can ditch expensive copper in favor of aluminum in the construction. The carbon footprint of production, according to the KIT Institute, is quite competitive with lithium-ion, especially considering that more than half of the pollution comes not from the battery chemistry itself, but from the enclosures in cooling systems. But there is a roughness we cannot silence. That is the water footprint. Early studies indicate increased water consumption in the synthesis of some cathodes. This is the very ecological compromise that engineers will have to resolve. Water or air, carbon or local pollution. We invite you to wonder, which costs seem more fair to us on the scale of our shared home? The most elegant part of this story is the ability to turn yesterday's trash into today's energy. Imagine, scientists have learned to take spent lithium iron phosphate batteries heading for disposal and, with a net profit of $2.62 per kilogram, turn them into cathodes for sodium batteries. Lavender waste becomes an anode with outstanding capacity. Even lignin from paper mills and old sea salt get a second life in the world of high technology. This is no longer just recycling. This is a reality upgrade. Sodium-ion batteries are perhaps the most convincing argument against resource wars. There is no cobalt from conflict zones here, no lithium scarcity. But as often happens, one dependency is replaced by another. Today, over 80% of the world's production capacity for these safe elements is concentrated in China. Can the rest of the world localize this essentially simple technology? This is no longer just a question of engineering, but of geopolitics. From a physical safety standpoint, the breakthrough is evident. Batteries certified to UL standards and prototypes described in Nature Energy withstand nail penetration and heating up to 300 degrees without catching fire. A calm, cold fire instead of a raging flame. Where is this technology indispensable? Where the cold bites to the bone. At -40, a sodium-ion battery retained up to 90% of its capacity. It is an ideal candidate for artificial intelligence data centers where energy loss equals millions lost, and for underground mines where a spark equals a catastrophe. And where is it excessive? In a premium sports car racing across half a continent without stopping. MIT named this technology Breakthrough of the Year, noting that its most significant effect will be felt not on the road, but on the grid. And here lies the main question of priorities. In what climate will this technology reveal its soul? And in what climate will it be just a heavy burden? It is interesting that nature has been operating with sodium for millions of years. We know plants that pull excess salt from saline soils, such as sea blight or the common sunflower. There is a deep rhyme in this, a technology that extracts energy from salt, and a plant that cleanses the earth of it. Two different manifestations of the same chemical cycle. The speed of progress today depends on the openness of code. Any researcher in the world with just a laptop can download the PyBAM or BATMO framework and model the behavior of a sodium cell more accurately than entire institutes could a decade ago. This is a weapon against the monopoly on knowledge. We will leave links in the description. These tools are free. So here we have a technology ready to be scaled tomorrow. It is cheaper, safer, and independent of the whims of global geology. We do not know what decision you will make after watching this. Perhaps you will simply remember the numbers, $40 per kilowatt hour and 20,000 cycles. Or perhaps one day, looking at your electricity bill or choosing your next city car, you will recall this quiet, salty heart of progress. We are not calling for immediate action. We are simply marking a fork in the road. And now, After we have together admired the beauty of engineering and the cleanliness of this futuristic car, let us allow ourselves one uncomfortable but honest pause. We have just been looking at this beautiful car, at its perfect gloss which reflects the beauty of the world around it. Hardly any of us would think of spilling something on the seat, spitting in the cabin or on the bodywork, or leaving trash on the mat. We protect our interior. We wash the body to a shine, especially when the car is new. But rolling down the window, someone will toss a cigarette butt or other trash onto the roadside and feel no discomfort. Because outside the window is not our home. The river is not our water pipe. The forest is not our apartment. But today, we are learning to respect the planet as our own home, as an extension of ourselves. Perhaps, reflecting on this contrast, someone will feel for the first time that nature deserves greater respect. Nature waits for our attention, just waits. Thank you to all who understand and who treat our shared home with care. See you in new videos on the Living Planet channel.